Hello, geometry. Welcome to 5.5. Use inequalities of a triangle. There is an important theorem coming up. It's called the triangle inequality theorem. So hopefully this shouldn't be that tough. But I want to say congratulations, Alex. I went to Annie on Friday night. Had a good time. All right, here we go. I can find possible side lengths of a triangle, and I can find possible distances. Okay, notice the word possible, okay? So here we go. Let's do a little warm-up, and recall in our title we have inequalities, and look at this. The warm-up has inequality symbols, okay? Well, here we go. Solve. I'm going to do the work over here on the side here. 3x plus 8 is less than 29. I'm going to subtract 8 on both sides. 3x is less than 21, then divide by 3. X is less than 7. Okay? You might have recalled, like in algebra, if you were to graph this, you would have, it's really light, usually you have to locate where 0 is and where the respective value is that you're using. This is going to be an open circle because it's not. There's no equality. There's no line underneath the inequality, and this arrow is pointing to the left, so you shade to the left. But the arrow only indicates what direction you're shading is if your variable is on the left side. Okay, let's go to black. Maybe that'll help. Let's do problem 2. 15 is greater than negative 2x minus 9. I see a negative right here. It's going to be interesting. Here we go. Let's add 9 to both sides. Negative 2x is greater than 15 plus 9 is 24. Then I'm going to divide by negative 2. Now, do you recall what happens with an inequality when you divide by negative? The inequality, let's put this in red, is going to flip. 24 divided by negative 2. Can you even see the red? How come it's not coming out? It's so strange. I just did that in red. Yeah, maybe that's better. 24 divided by negative 2 will be negative 12. This always drives me crazy when it's written like this. I like to write it like this. X, notice the open parts towards the x, is greater than negative 12. Okay, now this one, a little nutty, but doesn't have to be too bad here. Just because we have a set of parentheses doesn't mean we can't do anything with it. 2x minus 2 is less than. I'm going to combine my x's here. We have 4x minus 12. Minus 12 when I combine those integers. And then I'm going to subtract 2x on both sides. Then I'm going to add 12 to both sides. And then divide by 2. X is greater than 5. Okay. Find all the integer. Notice it's oh, I spelled integer wrong. Didn't notice that. Integer. Solutions for 4 is less than x is less than 11. So 5, 6, 7, 8, 9, and 10. You're not going to use 4 and 12 because there's no equality symbol here. If there's an equal sign there, then we would include 4, not 12, 4 and 11. All right, triangle has the measure 82 and 34. So find the measure of a third. Take 180 minus those two angles added. You're going to get 64 degrees. Okay, so here we go. And this is where I'm going to need some color here. I wonder if the Sharpie is going to work a little bit better. Where's my blue Sharpie? I'll have to use this. Okay, so shown is a scaling obtuse triangle and a scaling acute triangle. Mark the longest side and the largest angle in red. Okay, so this looks like my largest angle. Can you see that red here? And then here's the longest side. Okay, you know what? I'm going to go like this just so it stands out a little bit more. And this one, this says 80 degrees. This is my largest angle, and then this is my largest side. Then it says mark the shortest side and the smallest angle in blue. So the shortest side is right here, and the smallest angle is this one. Here, my shortest side and the smallest angle. Okay, I don't want you to assume that these are congruent. Not, I better write that down. Not congruent. Okay, I just want to show emphasis on the side lengths. What do you notice? Well, the largest angle and longest side are opposite of each other. Ooh, crazy R. And that's supposed to happen all the time. It'll kind of help you remember what's going on with isosceles triangles. All right. So if one side of a triangle is longer than the other side, okay, so given, let's mark AB with red. Then AC, we'll mark it with blue. Just, kind of keep it consistent with that up there. Then, this angle, which is side opposite, is larger than this angle. What do you think? Not side opposite, angle opposite. All right, so I always kind of think of it like this. Say we have an angle on a pair of scissors. What's going to happen if I make this angle bigger? Look at the side length, side opposite. If I make that angle bigger, what's happening to the side length? It's getting longer, okay? If I make the angle smaller, what's happening to the opposite side length? Then it's really little. All right, let's flip it. Okay, now this page looks a little bit different from your page because I fixed it. So, particularly this picture. Basically, I have the wrong picture here. I wanted to start with, because this is the converse, the angles. If one angle is bigger than the other, so this angle is bigger, so the side length is bigger. So you're going to start with the angles, then the side lengths. Then, if this angle is a little smaller, make sure blue is marked, then the side length is smaller. Okay? So that's what's going on. So theorem 511 is just the opposite. Start with the angles, then you have the sides. Whereas theorem 510 was start with sides, then you have the angles. And they're only comparing inequalities, okay? Let's look at example 2. 3 wooden beams will be nailed together to form a brace for a wall. The bottom edge brace is about 8 feet long. And the sides are about 12 and 14. Okay, let's see here. So this is about 8. Let's make this 12 and make this 14. Okay? One of the angles must measure about 86 degrees. And the other measures about 35. What angle measure opposite, and I think I fixed that on your page, is the largest side of the brace? Okay, well, I'm going to take 180 minus 86 plus 35. Hence, we kind of did this in our warm-up, didn't we? We're going to get 59 degrees. All right, so these are the 3 angles. Let's kind of match them. This is my smallest side, so the smallest angle needs to go up here. So that would be 35 degrees. Okay, this is my largest side, so the largest angle has to go opposite. This is 86. Should have made that degree symbol smaller. And then, of course, this will be 59. Because that's like the middle side. Okay? So what is the angle opposite of the largest side of the brace? So here's your largest side of the brace. The angle opposite is 86. All right. Ooh, look at this. A proof. It's about 9 statements long, so bear with me. All right, here we go. Let's put a big line here. Basically, we want to prove theorem 510, and this is in your book. Okay, so theorem 510 is page 311. 330. What am I getting? 311. 331. Yeah, a little dyslexia going on today. So we're going to start with given. Number 1, we have segment AB is greater than BC. Okay. Remember what theorem 510 says. If you have one segment greater than the other, then the angle opposite will be larger than the other. Okay. Step 2. Locate P. Now, I know this seems weird. You usually don't do proofs like this, but you do have to introduce things sometimes. Locate P on AB. Okay, our picture has it right there. Such that BP is equal to BC. All right, so you see the little lines here. So we want to find out where P is just so that happens. Okay, then draw CP. Okay, how can we justify that? 2 points make a line. Remember those definitions back in the old day in chapter 1? Well, there you go. Okay, now what kind of triangle do I have here? I have an isosceles. So I'm going to label this 1, label this 2. If we have an isosceles triangle, if I know these two are congruent, then the base angles are congruent. So step 3, angle 1 is congruent to angle 2. Base angles of isosceles triangle are congruent. It's a bad triangle. Okay. Now, measure BCA, okay, this whole thing, is equal to, let's also name this angle 3. Makes life easier. BCA is equal to angle 1 plus angle 3. Okay? Hopefully you see where this is going. Measure of angle BCA is equal to the measure of angle 1 plus the measure of angle 3. All right, what did I just do here? I should say that the measures of these are congruent. I think I might do that a little bit later. We'll see. All right, what is that? If I can take these two, add up to equal the whole thing, isn't that angle addition? Okay, number 5. The measure of angle BCA is greater than the measure of angle 1. Do you agree with that? Because BCA would be these two added. So BCA has to be greater than this one. It's greater than the measure of angle 1. Okay, so let's see here. My ruling on here, I have definition of an angle. I think I have an issue here. I'll have to look at it. I'll look it up later. Definition of an angle. All right, number 6. Now, keep this in mind. Remember I told you I should have said that the measure of angle 1 is equal to the measure of angle 2 in there? This is why right here. So the measure of angle BCA is also greater than the measure of angle 2 by substitution. So I just substituted 2 in for angle 1. 7. Okay, so the measure of angle 2 is equal to the measure of angle 3 plus the measure of angle A. Where did that come from? Okay, now if I cover this up, this plus this, if we add them up, is equal to that angle. This is your exterior angle theorem. Remember that? This is pretty nifty. Okay, number 8. Measure of angle 2 is greater than the measure of angle A. How do I know? Angle 2 is equal to these two things added. So measure of angle 2 has to be greater than just one part. Definition of an angle. Again, I'm going to look that up. Not sure where this popped up out of. And then last but not least, the measure of angle BCA is greater than the measure of angle A. Because BCA is greater than measure of angle 2. Measure of angle 2 is greater than measure of angle A. So BCA is greater than measure of angle A. So that's transitive. Okay, now where are we going with this? Measure of BCA, that's this whole thing, is greater than just this one. Okay, the side opposite is this line. The side opposite just part our angle 1 is this side, but we have this whole side. Remember what we're trying to prove, that this whole angle is going to be bigger than just that one, and we did it. So I think it's kind of a nifty proof. Would I expect you to come up with that? No, it'd be awesome if you did, but it's kind of tricky. Do you see all that? All right, so not a lot going on this page. Triangle inequality. Not every group of 3 segments can be used to form a triangle. The lengths of the segments must fit a certain relationship. For instance, let's say I had a triangle that was the lengths 4, 5, 10. Well, what's the problem? If I flatten these both out, they're never going to touch. 10 is longer. How about these? 1 and 2. They'll touch, but right on this leg, this opposite side. So, Theorem 512 is your triangle inequality theorem. Here it is. This one is your important one. The sum of lengths of any 2 sides of a triangle is greater than the third. Okay, so if I take AB plus BC, these two have to be bigger than AC. Or BC plus AC, these two, has to be greater than this one. Or if I add up AB and AC, these two have to add up to be greater than that one. So triangle inequality. Yeah, it seems obvious, but I got to work on it. A triangle has one side length of 11 and another side length of 6. Describe the possible lengths of the third side. All right, so let's say this is 6 and this is 11. What does this have to be? Okay, we cannot put a 5 here. Why? Or a 3. 6 plus 3 is 9. 6 plus 3 is 9. Remember, 2 sides have to be greater than this. If I put a 5 there, nope, not enough because it'll be equal. But if I put 5.1, that'll work. So, any value greater than 5. This is 1. Oh, that's really hard to see. One of those triangles. Okay, looking for a better angle. Does not exist. There we go. What if I do it this way? This side length is 6, and this side length is 11. What is this side length going to be? Well, 6 plus 11 is 17. So your x, this side length has to be greater. X must be greater than 17. Wait. Sorry. I messed that up. X has to be less than. Because these two have to be greater. These two add up to 17. This has to be less than. If this was greater than, they wouldn't meet. So x has to be less than 17. So your side length can be anywhere between 5 and 17. All right. So you have to pose both sides. Most people always do this one. They forget that this can exist. So here's our homework, and there is our Common Core standard. Have a nice Saturday, and good luck for your last night, Alex. Hopefully the after parties are a good time. Don't stay up too late.